everyone, welcome to GemChem. Now today's video is on 15 important questions in the form of MCQ and NAT type based on the chapters of Kinetic Theory of Gases and Atomic Structure, Solid State, Ionicequilibria and Redox Chemistry. Now before starting, if you have not watched these videos, you can watch it. I will give the link in the description box as well as the I button above this video, that is here. Now let us start today's video. Now first question is MCQ type, that is multiple choice question. Now there are two sets of quantum numbers with same number of radial nodes. So we have to identify the quantum number sets which have same number of radial nodes. Now how to find the radial nodes we have already seen in Atomic Structure part 7 video. Now you can see the video for reference. I will give the link in the description box. Now let us see the formula. To find out the number of radial nodes, the basic formula is n minus L minus 1. Very simple formula, it is n minus L minus 1. Now if we check for the first one, the value of n is 3 and the L is 0. So 3 minus 0 minus 1 is equals to 2. For the next one, it is 2 minus 0 minus 1, it is 1. So we can see that the value is not matching. Whereas if we go for the next one, we see 3 minus 1 equals to 1, which is equals to next one. For the next one, we see 2 minus 1 which is equals to 0. So we see that this also do not match for the both cases. And for the next one, for the C, if we see, we get 3 minus 2 minus 1 according to the formula, right? So we get the value to be 0. And for the next case, it is 2 minus 1 minus 1, it is also equals to 0. So we have obtained our answer to be this one. So answer is option C, right? Now we will go for the next one. This is a MCQ from Solid State chapter. Now the reference for it is Solid State part 3 video. So you can watch it. I will give the link in the description box. Now monochromatic X-rays having energy 2.8 into 10 to the power minus 5 joule diffracted first order from 200 plane of a cubic crystal at an angle of 8.5 degree. The length of unit cell in angstrom of the crystal rounded off to 1 decimal place is Planck's constant given and C value given. So first we need to get the formula. So first we know that energy formula is E equals to hc by lambda. From here we will get the value of lambda. So what will be the value of lambda? hc by E, and it is equals to 6.626 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by the energy given is 2.8 into 10 to the power minus 15, right? So our answer comes to be as 7.09928 into 10 to the power minus 11. And we know from the Bragg's law that lambda, n lambda specifically, is equals to 2d sine theta. And in this case, since it is told that first order diffraction, so here value of n is equals to 1, right? So what we can get ultimately is that this value is equals to 2d sine theta, right? Now what? Now we will find out the d. So d will be just by substituting the value of sine theta here. So here it will be sine 8.5 degree and ultimately we will get the value as 2.40 into 10 to the power minus 10 meter, right? Now if we go for another formula where we know that the interplanar distance inverse square is equals to h square by a square plus k square by a square plus L square by a square, then this is equals to h square plus k square plus L square a square. Now we just substitute the value of d here and ultimately we get a square equals to 2.30688 into 10 to the power minus 19. And a comes to be as 4.8 into 10 to the power minus 10 meter. Now then our value is 4.8 angstrom. And here the option is option C. So the correct answer for this one is option C, right? Now we will go for the next question. Now see this one. The ratio of the nearest neighbor atomic distances in body-centered cubic and face-centered cubic crystals with same unit cell age length is. So we have to just take out the value of the nearest neighbors and then do the ratio. So when the nearest neighbor occurs, what do we mean by the nearest neighbor distance? This nearest neighbor distance refers to the value of d. Okay, always remember nearest neighbor value refers to the value of d. So we can find the value of d. We know for BCC, we have already seen in solid state part 6 that for BCC, for the body diagonal which is root 3a is equals to 4 into the radius of the molecules constituting the unit cell or the lattice points, right? So from here we can get that d equals to root 3a by 2. As we know that always d equals to twice r. This is always same, whereas this value changes and we just substitute the value of r from here to this equation to get the value of d here. Similarly, if we go for the FCC, then d equals to 2r is same and 4 into radius is equals to face diagonal length, that is root 2a, where a is the same unit cell age length, right? Now from here we can write d equals to root 2a by 2. Now if we name this as d1 and this d2, then d1 is to d2 comes to be as root 3 by root 2. And we can see the answer is, option is our option number A, that is this one, right? Now we will go for the next question. That is, this is a question from kinetic theory of gas. First try it on your own self, then start seeing the solution, right? So according to the kinetic theory of gases, the ratio of the root mean square velocity of molecular oxygen and molecular hydrogen at 300 Kelvin is. So we have to find the ratio of root mean square velocity. First we should write the formula, right? So what is the formula of root mean square velocity? We have already seen and derived the formula from kinetic theory of gases part 4 video. Details is given there. So it is equals to 3 kBt by m to the power half. Now m for O2 is 32, whereas m for H2 is 2, we know. So now here we take the ratio R1 by R2 if we consider the ratio to be as, then 3 kBt by MO2 half, then 3 kBt by MH2 half. Now this upper portion gets cancelled, that is 3 kBt root, and we are left with MH2 by MO2 to the power half, and the value is 2 by 32 to the power half, and it comes to be as 1 by 4. That is, C option is our answer, 1:4, right? Now the next question is from Ionicequilibria part 5 video, and there we had dealt with solubility product, right, and also discussed about the different group involved in inorganic analysis. So in qualitative inorganic analysis of metal ions, the ion which precipitates as sulfide in the presence of H2S in warm dilute HCl is. So those ions which precipitates as sulfides in acidic condition are group 2 ones, and that includes Hg2+, lead 2+, copper 2+, bismuth 3+, cadmium 2+, antimony 3+, and arsenic 3+. So here from this we can understand our answer will be D, right? So it will be bismuth. Now we will go for the next one. Now we start with NAT type question, that is numerical answer type question. Now see the question first. It is from atomic structure, right? And it is very simple. We have already studied everything in atomic structure part 1 video about this sum particularly. So a simple formula is required for this one. Okay. So first understand. Here it is told that the ionization energy of hydrogen atom is 13.6 electron volt, and the first ionization energy of sodium atom is 5.1 electron volt. Now the effective nuclear charge experienced by valence electron of sodium atom is what? And round off to 1 decimal place. So it is easy. First we will write the formula for ionization energy. It is equals to minus 13.6 into Z square N square. Now here we know that sodium is 1s2, 2s2, 2p6 and 3s1. So here the valence shell electron is present in N equals to 3, right, and on ionization it will go from N equals to 3 to N equals to 4. So a simple formula which is being used is ionization energy equals to minus 13.6 into Z square. So final state is 4, so 1 by 4 square minus 1 by 3 square, right, and this Z square ultimately is 3.375, which gives us Z equals to 1.837, but here already told that round off to 1 decimal place. So we will write our final answer to be as 1.8. Okay, so this is our final answer. Now we will go for the next question. Now this is from SolidState. So a first order reflection X-ray from 220 plane of copper crystal is observed at a glancing angle of 22 degree. The wavelength of X-ray used is dash picometer. Round off to 1 decimal place, and copper forms FCC crystal with unit cell edge length of 361 picometer. Now this is important question. Try once for your own self and then I will show the solution. Now this is particularly being discussed in SolidState part 3 video. Okay, so first we know that n lambda equals to 2d sine theta. This is from Bragg's law, right? So lambda equals to 2 into d into sine 22 degree, and here it is told that first order reflection, so n equals to 1, right? So now what is the formula for d? We have just now done a sum on it, so it comes to be as equals to 2 into a by root over h square plus k square plus l square into sine 22 degree. Now we know the value of a to be here as given 361 picometer. So we just substitute the value here, and h is equals to 2, k is equals to 2 and l equals to 1. So ultimately the value of lambda comes to be as near about 95.6 picometer, and here already told that 1 decimal place, so this answer is perfect. Now the next question is from buffer. Now 1 liter of a buffer solution contains 0.004 mole of acetic acid and 0.4 mole of sodium acetate. Now we have to find the pH of the solution. Now each minute concepts of buffer solution is being discussed in Ionicequilibria part 4 video. You can watch it. I will give the link in the description box as well as the I button present above this video. Now see, a basic formula for pH of a buffer solution is pH equals to pKa plus log 10 concentration of the salt by concentration of the acid. This is very basic. Now here we have already given pKa 4.76 plus here log 10 salt concentration is given to be as 0.4 and here 0.004, right. So this ultimately comes to be as near about 6.76, and since it is told round off to 2 decimal place, so this answer is perfect. Now here this question is from redox chemistry. Now see, for the reaction copper sulfate plus zinc produces zinc sulfate plus copper, the value of delta G0 is, so we have been asked for the delta G0 value. So in the first video of redox chemistry we had already discussed the formula of delta G0, which is equals to NFE0, right, and with a negative sign. So from there only we can solve this problem. Now first we have to find out the value of potential. Now we know copper 2 plus here in this reaction reacts with zinc to form copper plus Zn2 plus, right. So E0 value for this one will be 0.34 minus 0.76. Okay, and the value will come to be as 1.1 volt. So we just substitute here the value minus n. So here electron transfer is 2 electron transfers, so value of n is 2. So here 2 into 96485 into 1.1, and the answer comes to be as minus 212.267. But here it is told that round off to nearest integer, so we write 212, and this one is our answer, right. Now we will go for the 10th question, and this question is from kinetic theory of gas. Now here we are going to find the molar mass using speed distribution. Now this particular topic is being discussed in part 4 video of kinetic theory of gas. You can watch it. I will give the link in the description box as well as the I button present above this video. Now let us start. First of all, from this one, from diagram only we can find the most probable velocity. We had dealt with a graph where the highest peak is being considered as the most probable velocity, and here it is 500. The peak is at 500. Okay, and the value or the formula for the most probable velocity is root 2 RT by M. Now if we carefully look at this, R value is being given, temperature is also being given, we need the mass, and 500 is our speed, that is most probable velocity. Now we just substitute the value, and then M comes to be as 0.01992, but the value has come in kilogram per mole, but we need the value in gram per mole, so it is 19.92 gram per mole, and this is our answer. Now we will deal with the 11th question, which is based on solid state part 6 video. So fullerene crystallizes in an FCC unit cell. Age length is given with one C60 centered at each lattice points. So So the smallest distance between the centers of two C60 molecules is what? So this is a very easy question. We have already seen that FCC has D equals to 2R and the 4R is equals to the phase diagonal, that is root 2A. So from here we can get A equals to 2D by root 2 and D equals to root 2A by 2. So here we just substitute the value of A, which is given as 14.14 angstrom, and we get the value to be as near about 9.998. But here, since it is told to round off to 2 decimal place, so we can write the value to be as 10.00, and this is our answer, right? Now we will go for the 12th question, and here we have seen that it deals with the chapter of atomic structure part 1 video again. So this is easy. Let us see. The longest wavelength of the light absorbed by a hydrogen-like atom is 2.48 nanometer. The nuclear charge of the atom is what? Round off to the nearest integer. So here same formula is being used where Rydberg constant is present. So 1 by lambda equals to RD Z square 1 by Ni square, that is N initial minus 1 by Nf square. So here it comes to be as, since it is coming from 1 because it is hydrogen like and it is going from 2, so N1 to N2, so it comes to be as RD Z square 1 by 1 minus 1 by 4, and it comes to be near about 7, because if we substitute here the RD value, which is actually our RH value, and here we substitute the lambda value in nanometer, then we get the value of Z to be as 7. Just substitute the value, you will get the answer. Now an important thing is that since it is given in nanometer, we have to convert it to the centimeter, because always remember here it is centimeter inverse. So this one must be converted into centimeter by taking it as 2.48 into 10 to the power minus 7 centimeter. Okay. Now this is the 13th question. Now here we will deal with Boho radius, and this is an important concept and we have seen it in atomic structure part 1 video, right? So see this one. What is the formula for Boho radius? R1 is equals to Rn, suppose, is equals to n square h square by 4 pi square m z square. Okay. Now we know for R1 it is given to be as, see here, given that the radius of first Bohr orbit of hydrogen atom is 53 picometer and we have to find the radius of third Bohr orbit. So R1 is equals to here h square by 4 pi square m z square equals to 53, right? And we need R3. So here 3 square into R1, the same thing, that is this portion is common. So we can put it as R1 here, right? So just putting this one, we get n is 3 square, so 9 into R1, that is it is equals to 9 into 53, and the answer is very easy on multiplying 477 picometer. So 477 is our answer. Now the 14th question is from solid state. Now calcium crystallizes in SCC lattice of unit cell length 5.56 angstrom and density 1.4848 gram per centimeter cube. The percentage of Schottky defect rounded off to 1 decimal place in the crystal is. Now this is an important concept. This is only discussed as a theory portion, that is Schottky defect, in this part 6 video, but here there is a numerical on it. So this is very important question, right? So this concept must be understood. we have seen while dealing with the difference of Schottky defect and Frankel defect that Schottky defect causes a difference in density, right? So this particular percentage can be obtained by using the density formula. Now see, if we take the percentage of Schottky defect to be as X%, then if we try to write the density formula, which is equals to into M by NA A cube, right? And since there is a Schottky defect occurring, so there must be some defect with the same density but a percentage of it. So Z into M by NA A cube X by 100. This is the percentage, right? So if we just take the common things out, that is Z M NA A cube, and we are left with 1 minus X by 100. Now we can easily substitute the different values here. That is, for density the value is given to be as 1.4848, and for the unit cell length A is given to be as here the value to be as 5.56 angstrom, which we need to convert into centimeter, that is 10 to the power minus 8 centimeter, and the Avogadro number is also being given, and atomic mass is also given as 40 gram per mole. So on substitution, ultimately we have to get the value of X, and the X comes to be as 3.9305. And it is very important to understand that here it is told that round off to 1 decimal place. So our ultimate answer will be 3.9. This is our answer. So this is important question, and we have to remember that this is our answer, 3.9. Now this is the last question of this particular video, and it is also important. See this one, this is from buffer solution. Okay, now see, here a buffer solution is being prepared by mixing 0.3 molar ammonia and 0.1 molar NH4NO3. If Kb is being given for ammonia as this one, then pH, we have to find the pH. Now we know the formula of PaOH, right? It is equals to pKb plus log 10 of salt concentration by concentration of base, and pKb is given by minus log 10 Kb, right? So we just get the value of minus log 10 Kb from using this one and then substitute the salt concentration. So let us do that. Here it comes to be as 4.79588 plus log 0.1 by 0.3, and it comes to be near about 4.31888. Now we require the value of pH, right? So we require the most important thing, that is value of pH. So value of pH can be obtained by 14 minus 4.31888, and it comes to be as 9.6812. And here it is told that round off to 1 decimal place, so ultimately we get the value as 9.7 because 8 is present, so the value comes to be as 9.7. So this is important. So 15 questions are done, and these questions are very important for BSc first year syllabus. Hope it was helpful. Now the last question, which is the 16th question, it is a homework for you. Try it on your own self. Next day we will discuss on it when this series again continues. So this is a NAT type question, and the value of answer have this range. So you can solve it and check with the answer. Okay, so hope this series was helpful for you. Thank you for watching. Do not forget to like, share, subscribe and comment.